Next we have here Robert Silen, who is giving us a presentation of building RAG AI application with MariaDB, Vector and Python. Go ahead.
Yes. Hello, hello. Thank you. Brilliant to see you all here. Good afternoon to you. Hope you had a good lunch. Yes, so I'm Robert Silen from MariaDB Foundation. I work with as a community advocate there. Some of you Python people from Finland might have seen that we did with the Helsinki Python group a hackathon last spring about this subject, so doing RAG with AI. Is this familiar for anybody? Okay, so one, okay, but mostly green field. Okay, great. So also on the abstract there was a mention of Kai Arnö, my colleague who's executive chairman at MariaDB Foundation. He's not, he couldn't attend this time, so it will be me doing this. So I'll be doing this talk. Small disclaimer. Wait, why is it not showing? There we go. So small disclaimer, I'm not a super database expert. I haven't been working decades with databases, but I do know something about Python. I have been playing around with AI and RAG and have formed an opinion on these things, and those I want to share with you today. So what is the agenda that we're going to look? I'm happy you're here to listen about AI. Some people might think, oh no, another AI presentation, but I hope I have something unique for you to learn here. And of course, I'll be showing what MariaDB's role in an AI ecosystem is and what the database role is in an AI solution. And in the abstract was also mention of an MCP demo. Whatever remaining time is after my presentation, we'll use at showing some practical things with that. Okay, let's get going. So let's be honest, AI hype is everywhere. Everybody is talking about it. And much what we're seeing is, however, built on shaky data, shaky input. And without good input, you're not going to have the quality that you want from AI. But let me say, the hype of AI is justified. It is doing very impressive things, but there's a lot of noise. And us as Python developers, we need to find what is possible and what can really make a difference for the end user. And from MariaDB, our message is that the data is the core of AI. So you've all heard garbage in, garbage out, and we're saying that a structured database is key to making a good AI solution. Data that is clean, structured, and queryable. It's not just nice, it's a strategic asset. And that's what's going to separate a nice demo on your laptop from actually running something in production for millions of users, which of course is the goal for all of you. Because that's where the database comes in. The database makes it possible to scale to large volumes and provide that data that your AI application needs. So developers might think, well, the database is just storage. I might as well save things in a JSON file or text file, or it doesn't really matter. I'll pull it from somewhere when I need it in my application. But when you're working with LLMs, vector embeddings, and RAG patterns, then the data becomes active infrastructure that you'll need to think about. So if you're going to do an AI RAG solution, you'll be using high dimensional vectors that you'll be storing and retrieving, and you'll need to do it efficiently. And you need a high performant database to do that. And that's not the database of the 90s that we're talking about. So it is a paradigm shift for databases. The database is part of your AI pipeline. So to do a quick recap, in the 90s, databases were all about SQL and ACID transactions, making sure your bank transfers don't lose money. In the 2000s, we were looking at scaling and replication challenges. How do we handle millions of users? And in the 2010s, it was about cloud and flexibility. JSON everywhere, schemaless designs. And now in the 2020s, we're in the era of AI native queries. We're not just asking, give me all users where age is larger than 25. We're asking, find me all documents semantically similar to this customer complaint, or retrieve context relevant to this user question. The query language now extends beyond exact matches to similarity, semantics, and context. And this is where the vector database comes in. But do we need a separate vector base, or can we extend what we already have? So I've been mentioning vectors now here. How many of you here have used vectors for something? A few hands not coming up. Let's take a quick recap of why vectors matter and why I'm talking about vectors in the database. So first question is, what is RAG? So the problem is that when you're prompting an LLM, it won't have the exact answers to questions you want. If you want to provide it with data about your users or user-specific data, it won't be able to give that. So we want to prompt an LLM with relevant data that the LLM can use to answer a question. So without RAG, I don't have any idea what the answer is. With RAG, it actually retrieves the data that it can answer you with. So why are vectors relevant for this problem set? Well, I was mentioning semantics. Semantics means similarity. And for a query to work, we need to find data that is relevant for your question. Now, vectors represent text or things. And it can be just a word or it can be a whole document. So this is an example of a two-dimension vector, and where the dimensions are size and speed. So in this world, a clock will be very far from a cow or a bike or a bird. And for those interested in the maths of this, you can, of course, check similarity either with cousin similarity or Euclidean. So Euclidean would be the actual distance between the clock and the bike, regardless of where they are on this. Whereas if you're calculating cosine similarity, as long as it's pointing in the same direction, regardless of how far they are from each other, then they're similar. This is a cool maths insight to realize when we go further along in this and why we're actually doing cousin similarities. So I ask a question about a cow, and I would rather have data about cows than about eagles. I think this is clear for you. And this is with two dimensions. When we're storing embeddings that come from OpenAI, we'll have over 1,500 dimensions. So it becomes very non-trivial how that is handled. So let's take a quick, very practical look at how a RAG solution would work. So when we're acquiring data and inserting it into the database, in this case reference documents, we'll create a vector representation of that. We might split the documents even into smaller parts, but we make a vector representation of it. And we put those vectors together with the text into the database, waiting for our query. And here it comes. The user asks a question, and we vectorize that question. And now we have a question that is a vector, and we have the database full of vectors, and we can do a vector similarity search. Which data is closest to the question I'm asking? So now we have some context data. And that context data, we combine that with the question I asked, and now we can give that to the LLM to provide an answer to us. And then the user gets the generated answer. By the way, this image is from the Wikipedia article about RAG, so very open source presentation here going on. Okay, but now since you got the basic idea of RAG, let's go forward to why we think MariaDB is relevant for you. So at the moment, there's basically 3 large open source databases available for you. You have MySQL, MariaDB, and Postgres. And MariaDB was born from MySQL as a fork from it. When MySQL got acquired by Oracle, it was forked and started living its own life. And not only that, but it got picked up by Linux distributions as a default. Wikipedia is running all its data on MariaDB. It has a very wide adoption. And you could say we at MariaDB Foundation, we're committed to developer freedom and open standards. No vendor lock-in, no surprise license changes, no pulling features into proprietary versions. We strive for everything to be open, transparent, and community-driven. So we can think of it as if AI is the new electricity powering everything we build, then open data is the new democracy. So we want to ensure that the foundations of AI remain accessible to everyone and not just big tech companies. Because the option of, for example, having your vectors in something else than MariaDB, an open source solution would be to have them in a proprietary vector database that you have to pay for, that isn't open. So let's talk about MariaDB Vector. So it has native vector capability in MariaDB. So it comes out of the box as a feature in MariaDB from version 11.8 forward, I believe. And it's specifically made for AI workloads. It's not a separate product or an add-on. Like I said, it's built in. So you can store, index, and query embeddings directly in MariaDB right alongside your traditional data. It's compatible with all major embedding models. So you can use OpenAI, as I mentioned, or models from Hugging Face, or your local LLM that you're running locally, Anthropic's, whatever, you name it. All these vectors can be stored in MariaDB. So this means you can vectorize your user profiles, your product catalog, your transaction history, and their vector data embeddings can all be in that same database where you have them in MariaDB. Queryable with the same connection, managed with the same tools you already use. So I mentioned that the other option would be to have your vectors in a dedicated vector database like Pinecone or Weaviate. And that's a fair question to raise. Why not use those? I mean, they're dedicated solutions. They have to be good. But the answer is simplicity and reliability. So having to run external vector stores means more infrastructure. Not using them means one less thing to deploy, monitor, maintain, one less thing that can go down at 3 a.m., one less data synchronization problem. And secondly, ACID meets AI. Your vector queries are transactional. You can update a document and its embeddings in the same transaction. So you don't get consistency issues between your data and your vectors. And thirdly, it's an easier deployment with the same SQL skills and tools that you would already have. So if you already have knowledge of MariaDB, it's very easy to start using vectors in MariaDB too. And of course, backup scripts, monitoring, all this will work for your entire solution without a new component in your ecosystem. So how does it look like in practice? So here's an example of SQL code to create a table where you're inserting text along with the vector. So before this step, you've sent the text to whatever embedding service you're using, and then you insert it into your table. So yeah, we're creating the table, and then we're inserting things. And then the select example here is how to look for that closest relevant text or closest relevant data that you want to find. So in this example where I was mentioning the cosine and Euclidean, so we're using cosine function here, and we're looking for the column embedding, and then the query vec is what we're looking for, and it's returning many vectors, but we're limiting ourselves to the first 5, the top 5, the ones that are closest to our question. And as you can see, this is just regular SQL. So you'll able to also combine this with where and joins with other tables to, for example, limit it to a certain data set, a certain region, certain users, whatever you need. So how do you use this in practice from Python? Well, you can use in Python the standard MariaDB library. On your Mac, brew install MariaDB, or you can use ORMs like SQL, Alchemy, or PyMySQL. They'll be able to work with it. So the pipeline is straightforward. You generate the embeddings, as I mentioned. You store them in MariaDB, and then with the queries, you fetch the vectors. So this is what it would look like with some pseudo Python code. So let's take one more look about comparing it to other options. So as I mentioned, there's Pinecone and Weaviate and other options to save your vectors, or if you're running it just locally, you're saving your vectors in a, well, I don't know, maybe pandas or something else, but this is the argument for running MariaDB, is that you would have both your data and your vectors in the same place. So MariaDB vector has been, let's talk benchmarking and speed. So MariaDB has been compared to PG vector with Postgres and the other solutions I mentioned, and MariaDB's vector search has been giving some very impressive results with these capabilities, and I recommend to Google those if you're keen to see more. Yes. So many AI database solutions that are available and coming out on the market are proprietary. They lock you in with closed formats, proprietary APIs, and licensing that can change at any moment. But MariaDB is different. We're open. We can't even change the license of MariaDB because of the history. We're transparent and we're community driven. And you see every line of our source code. So if you find a bug, you can even you can report it and even fix it yourself. Both an ideological and a practical argument for why to use open source MariaDB. And since we're an open source project, let me encourage you to participate. So you can try out MariaDB Vector at this address. It has some really nice videos and examples of how to do these examples I've been talking about here, AI RAG, and also has more in-depth technical presentations about the performance and how vector search in a database works. So if those things float your boat, take a look at that. But please, if you play around with it, make your test available on GitHub, join our MariaDB community events, or if you find bugs or have improvement suggestions, take part in the MariaDB channels and make yourself heard. It's very appreciated. So in the future, there's a lot of options where MariaDB vector search can go in supporting your AI applications. But the main goal is to make MariaDB easy for the user, and by making it easy for you, it will become the universal data layer for AI applications. And with the help of MariaDB, your SQL database is about to get a PhD in semantics, is a nice quote. And for those that are here pondering how learning about vectors and AI RAG can help you career-wise, or what kind of job opportunities this raises, let me mention that it is highly central. I just sat in at lunch talking with somebody who's building AI RAG solutions for work. It definitely is something that the industry is looking into, and the technology is evolving all the time, and I'm sure there are arguments against why AI won't work or why AI RAG isn't good. It only answers correctly in so and so many percentage of the time. But this stuff is going forward fast, as we all know. What was half a year ago not possible is possible today. So it's definitely a train to be on and to ride and learn the latest ways of doing things. And you don't have to be a machine learner expert overnight. There are so many easy frameworks to start from to learn these things. So let's go on. Absolutely. So in our presentation, in my abstract, I was also promising a hands-on demo of how to do these things. So I mentioned in the beginning that we had a hackathon with the Helsinki Python meetup group. And the winner we had two tracks, innovation and integration. So in the innovation track, the winner was a guy who made a hackathon contribution with YouTube. So doing semantics on YouTube. So he transcribed a lot of YouTube videos and vectorized that from lots and lots of hours and hours of presentations at various Python conferences. And then he was able to find, by vectorizing small parts of it, he was able to find, okay, where has somebody talked about a certain topic, and was able to pinpoint presentations where a certain topic has been discussed. So that was a really cool example of using vectors and semantics in a search use case. But the hackathon winner of the integration track was for the MCP server. I don't know, have anybody here heard about MCP before? A few people? Yes. And David Ramos put together a really nice example of doing AI RAG with MCP. And afterwards, it was actually, as you can see, his hackathon repo is there, and it was actually MariaDB adopted it as a contribution to the project and actually built forward with it. So it's not just doing AI RAG now, but you can actually talk with your whole MariaDB database through this MCP server. So that repo is also available now. And those blogs are quite nice if you want to read more about using MariaDB in RAG from those hackathons, or just using MariaDB semantic search. But let's go in on a practical level. So I'm going to do a quick, very practical, how to get an MCP server running. But before that, do you have any questions so far? If not, I'll show a bit what I'm doing here, and you'll just see what that means in practice. Maybe I should explain what an MCP server is first. You've heard the name, but do you know what it is? Does anybody know? Does anybody need a more? You want to know or you know? You know. Well, the idea, these AI frameworks, the idea is that to make it easier for you to use AI, to make these AI RAG solutions. So the MCP basically puts a wrapper around the MariaDB database, and then when you call it, you don't have to know exactly all the small syntaxes and things, but instead you query it with a natural language, and it understands what you're trying to do. It knows what kind of things it can access the database with, and it takes care of that. And then it returns a result to you. So you don't actually need an SQL query to do the RAG. So it's an interesting setup to try out. So David made, this is his hackathon contribution. And I'm going to quickly show this. So I'm not sure how hands-on you would like this to be, but basically I've git cloned this into locally. Wait 1 second. This is not going to work like this. 1 second. Well, let's do it like this. So basically the steps for running this is to set up let's do it like this. So in this case, we're running MariaDB as a Docker image. So we're taking the latest version of MariaDB. Now we have a running MariaDB in Docker that can be accessed on my computer locally. And one second. And then we're running the UV command. And now it's running. So now we have a MariaDB database running, and we have started the MCP server here. And in the final step, now we have a MariaDB MCP server already running that is wrapping the database. And then, for example, what would be an interesting way to connect to it? So I don't know how many of you have used Claude Desktop, but here is you go into settings and developer mode. And when you do edit config, this would have been empty, but I took this code from the README that David had provided and inserted it in the settings. And now I'm getting, now I see the MCP server here. And basically now I can, hello, do I have access to a MariaDB database? demo effect. Here we go. So it understands I want to be using this MCP server MariaDB database. And it's telling me, okay, I'm having connections issues with it right now, apparently. Well, it is running. But this was working really nicely about half an hour ago. I'm not going to go deeper in debugging this, wasting your time. But my point here was to show a very practical case that this is how you can set up an MCP server. You just start a MariaDB server. You use the nice JSON, for example, provided by David or in the MariaDB repo, and you can have access to this. Then you can, for example, prompt this to give it a JSON file, ask it to insert or some collection of documents, and ask it to insert it. And the LLM and the MCP will figure out how to embed them and insert them into the database. So it will be doing the vectorizing automatically. So that was my quick, dirty, how does this work with MCP part. But I've reached the end of my presentation so far. I'm happy to take questions. I might hack around with this a bit more, but I'm done for now. So thank you for listening, and I hope you learned something about vectors and RAG.
Okay, and any questions? I will bring the microphone to you. Here we go.
Yes.
One moment, I will just take the mic.
Yeah, hello, thanks for your talk. First of all, I've actually got like two more maybe questions. Maybe you can suggest something about using MariaDB with geospatial data and vectorization. Does it have some specific solutions for working with geospatial data?
For geospatial data?
Yeah.
I mean, it's supported as vector types and functions. Is there something specific you would want to do, or something specific you're...
Well, Postgres has the whole extension about geospatial data.
I'll answer. Yeah, Postgres has a lot of functionality around spatial data. I don't know where we're currently at, sort of what Postgres is able to do and what MariaDB is able to do. There might be a difference in that level, but yeah.
Okay, and the next question is about MCP. I noticed that it was mostly about different tools, but I was thinking that for vector embeddings, it's probably better to use resources of MCP because it has that kind of possibilities. Do you know why those were not used?
I don't know of this. It's David's hackathon contribution, so I don't know his exact choices for that. But I just realized I didn't show. Is it connecting again? Yep. His solution was only using the MCP for the vectors and RAG, but then the version that has been further developed for that, I should have also shared that. So MariaDB/MCP. So this version is the more advanced one where there's a lot more tools available within the MCP server. So it's yeah. Does this partly answer your question? I'm just saying that the MCP server can be further developed. So there's the vector store and embedding part, but here are the actual other options that you can use through Claude to ask for specific things related to the database.
I have a question about that server. Do you think at some point the MCP server would be kind of integrated directly into the database? Why does it have to be a separate server?
Good question. No, I think things are just going so fast now that it's easier to build a wrapper around things. But yeah, why not an AI being able to connect directly to it? And I mean, MCP, the P stands for protocol, so it should be a standard. So why not at some point it becomes such a standard that it's actually built into products? Yes. But I mean, this is sort of MariaDB's official MCP server that MariaDB PLC is providing. I mean, you can make these yourself also. There's a lot of MCP servers available on GitHub, but it gives that flexibility of if it's not built in, then you can change it and adjust it and build further on it.
Thank you. Let's give an applause to Robert.
Thank you.